So good morning again. If we're watching this video online, it means I've anticipated that I'll be absent again due to my famous situation that I described last week. So thanks again for your cooperation and tuning in. Hopefully this will be the last lecture that I need to give to you or deliver to you in this format. I very much prefer to be in class where I can answer questions and get a feel for how well we're comprehending the material as I go. Right. Maybe I didn't say it in the previous videos, but please, if you do have any questions after you watch videos, know that you can email me, get in touch with me. While I might not be on campus this week, I am definitely in electronic access or have electronic access and happy to answer questions. I want to make sure that we get off to a good start this semester. So we finished up chapter 6, a lot of good information on energy, and now we're ready to go back and get chapter 5, the other chapter that we skipped during the Chemistry 1 curriculum last semester for most of you. Chapter 5 is where we're going to talk about gases and gas laws. And so I'm going to prepare just, I think, 1 or 2 segments of video for us on that. I think that's all we'll need to get us on track with the syllabus before I'm back in the classroom for sure next week. So, gases. Gases have been studied for a long time. Very interesting history. You should check it out in the textbook, some of the stories that are related, the anecdotes. They've been studied, though, since before we had electricity commonplace and before we had standardized units of measurement. And chemists had to make their own measuring tools in a lot of cases. So to me, it's really fascinating that we learned as much about gases as we did 200-300 years ago, and that to this day the laws that were first discovered in those long ago times still are accurate and haven't really needed to be changed at all. So that's one of the reasons I think why people were excited to study gases back then. They could quantify their behaviors very accurately and consistently, which is a big part of scientific work, being able to reproduce something again and again. All right? So gases. It's easiest to think about gases when they're trapped in a sample, like a balloon, right? So I just drew a little balloon here, and there's some gas in there. If we want to fully describe that sample or any sample of gas, it turns out we need 4 properties to do that. All right? And we can measure a lot of things associated with that gas, but the 4 properties that lock in what that gas is and tell us anything else we want to know about that are going to be the volume, the temperature, the amount of gas, and the pressure. So most of these should sound pretty familiar to you. For volume, we want to make sure that we measure it in liters. That's going to be the standard unit that we use. So if we do measure a volume in milliliters in the lab, any calculation that we do with it is going to need to be converted to liters. For temperature, we're going to use the Kelvin scale. It's in fact gases and the relationship between volume and temperature that told us we needed a different temperature scale from the Celsius scale. And you want to remember that the temperature of anything on the Kelvin scale is its Celsius temperature plus 273.15. So for gases, you just want to commit right away to converting temperatures to the Kelvin scale. All right? I know last chapter we were able to work in Celsius, but now we want to get into the habit of always converting to the Kelvin scale. Amount. What does amount mean, right? So amount could mean different things, but scientifically or chemistry, we want to remember that the amount refers to moles. How many particles of the gas do you have? We don't want to quantify amount by mass because 2 different balloons could have the same weight. But if they're different gases, that means they have a different number of particles in them. And their behaviors are going to be dictated, we know now, by how many particles they have present in them. And then the last one is the pressure. Now the pressure can be measured in many different units. I'll show you a few of them in a second. But the atmosphere is the one that we'll want to use most often as the standard unit. Now, gas pressure is sort of the new term among this group, so let's talk about it for a few minutes. Pressure, in physics at least, is defined as the force that an object applies divided to an area. So imagine, some weight, a cylindrical weight, pushing down on an area, right? There's a force divided by an area. And the larger you spread that area out, the less the pressure is. Whereas the smaller that area is, the greater the pressure is. We use this to our advantage when we use a nail to drive into a piece of wood. We take all of the force that a hammer might apply to the wide head of the nail, and we narrow it down into an extremely tiny point, and that creates a tremendous pressure that then is able to drive into a piece of wood. If you turned your nail upside down and hit the tiny head, right, that force would then get spread out and the nail would not go into the piece of wood. We use this type of concept to go snowshoeing in the wintertime. If you've ever gone snowshoeing or heard of what that is, that's strapping a much larger shoe or footprint to the bottom of your foot so that your weight is now spread out over a larger area. Your weight, which is your downward force, applied over a larger area means your pressure is less than what it is when you just stand on your own 2 feet. And that reduction in pressure is enough that you can stand on top of snow and not sink into it. Maybe you've seen or heard of some insects that can walk across water. It's the same idea. They're spreading their weight out. This is also why you would want to lay down on ice if you're worried about it. If you were ever out on ice that you were worried about breaking and falling into the water underneath it, if you lay down, your area, it's now your whole body area that you're spreading your weight across rather than just the soles of your feet. So that's what pressure is. Now, how do gases generate pressure? Because they're not just objects sitting on things. So gases are moving particles, and when they collide with the walls of their container, that's when they exert force, just like our hammer to our nail. So it's the collisions of gas particles with the walls of the container that cause the pressure exerted by a gas. And having just 1 or 2 particles isn't going to do a whole lot for us, but having billions and moles of particles in a container is going to add up to a significant amount of force that's divided across the area of the walls of your container. And so that's how gases are able to generate pressure. All right? So I'll take a break here, and I'll come back in a second and real briefly show you how we measure gas pressures and what a couple of the instruments are. And then that'll set the stage for understanding how these 4 properties are interrelated to each other. And those relationships are the gas laws that we're really after in this chapter.